Hi everyone, welcome to day 5 of Just Enough Python for AI. So in the last video, we looked at lists and tuples. Today we will look at dictionaries and sets. So let's get started. Let's first look at dictionaries. So what exactly are dictionaries? I think all of us have referred to a dictionary in our life at least once, right? It could have been maybe English to English or English to Hindi or maybe between two different languages. But we have referred to a dictionary in our school life or even outside of it. So, what exactly is a dictionary in our normal life? If I can refer to a English to English dictionary, it's always a word that you refer to. You go and find a word in the dictionary, and then you find the meaning of that word next to it, right? That is the simplest way of understanding what our dictionary is. That word and then the meaning together are key value pairs. The word is the key, you look for a key, and then you find the value, which is the meaning of the word. The same concept applies here. We have keys and then we have values. So if you just look at this example here, right, we have name, then we have Ada Lovelace, then we have field, mathematics and computer science, and then contribution. So the name, the field, and the contributions are keys, and the values are, of course, the Ada Lovelace is the value for name, mathematics and computer science is the value for field, and then first programmer is the value for contributions. This is a key value pair. When you want to store a data that looks like this, you can't really use lists or tuples. You have to use something called dictionaries, and you have to store them in this particular format, that is key value pairs. Let's look at them in more details. And sets, what exactly are sets? Sets are also a collection of elements, but unique elements. We'll look at sets a bit later. Let's first focus on dictionaries. So as I mentioned here, your key is the name and the value is the Ada Lovelace. So now let's see how we can create a dictionary. And the very first thing you will notice here is that we have now a different kind of bracket. Now we are looking at a curly bracket, also called I think braces. So each built-in data structure that we have seen till now, list, tuples, and dictionaries, each of them are denoted by a different kind of bracket. That is the easiest way to understand what kind of data we are looking at, whether it's a list, whether it's a tuple, or if it's a dictionary. We'll also see how a set is denoted a bit later in this video. So what we have here is first the name of the dictionary, which is person info, and within that, within our curly brackets, we first have the key, then colon, and then the value. And we can have multiple of these key value pairs. Now let's execute this code and see how our dictionary looks like. So as you can see, we have our dictionary. It looks pretty much the way we have defined it. Key value, then a comma, then again key value, then comma, and then key value. We can have multiple key value pairs here. Now, what we would do after we create a dictionary, unless we can access the elements within the dictionary. So how do we do that? We do that by keys. Same way as you would use a actual physical dictionary. We go and find the word, which is the key, and then we find the definition or the meaning of that word next to it. So we access elements within a dictionary by the key. So here we are trying to find the value for the key name, and here we are trying to find the value for the key field in the dictionary named person_info. Let's try executing this code and see what's the output. As expected, our value for name is Ada Lovelace, and the value for field is mathematics and computer science. This is how you would access elements of a dictionary. Now, at times you would want to get a list of all the keys in the dictionary. So here, how many keys we have? We have 1, 2, 3 keys: name, field, and contributions. You want to get a list of all the keys. Then what we do? We can use the built-in keys method. We can say person underscore info dot keys, and this will give you the list of keys in the dictionary. Next, what if you want to get a list of all the values, not the keys, but only the values? Very easy. As the name suggests, you say person underscore info dot values. We use the built-in method called values. And you get all the values within that dictionary in the form of a list. And much like what we did with lists, we would like to add, we would like to update, we would like to remove these key value pairs from a dictionary. And let's see how we can do that. So dictionaries are also mutable, which means that it's changeable just like lists, and that's the reason we are able to do these operations, adding, updating, and removing from a dictionary. So this is how you will be able to add a new key value pair. Our dictionary name is still same, person underscore info. Now we are saying a new key that is born, and we are assigning a value to that new key, that is 1885. Ada Lovelace was born in 1885. So when we execute this code, you will see that a new key value pair has been added at the end. This is how we can update the value of an existing key. If you look at the value for field, in the original dictionary, it is mathematics and computer science. We are now trying to update it to mathematics and computing. Let's execute this code and see whether it gets added or not. Let's also print the whole dictionary. Person info, and we can see now that the value for field is now mathematics and computing. Next, we'll see how we can remove a key value pair. We will use the delete keyword, and we will give the key that we want to delete. This will delete both the key and the value. So here we had born and then 1885. Now this key value pair is gone. Now let's see how we can check if a key exists or not. There will be scenarios where you wouldn't know if a particular key exists in the dictionary or not, or based on the condition whether a key exists in the dictionary or not, you will take certain actions. In that case, you will need to check if the key exists or not. So this is how we can check if a particular key exists in a dictionary or not. So here is our dictionary, person info, and we are checking if this key name, the key name exists in person's info or not. If it exists, then we say print, yes, there is a name key. Of course, we have one, so it's printing, yes, there is a name key. If we change it to something else, if you just call it names instead of name, you will see that we get nothing, because names as a key does not exist in our dictionary. We will change it back to original. Now, dictionary is also an iterable object. That means that you can loop through the elements of the dictionary, and that is what you will often do. So how do you loop through the keys? Now, this is how you will loop through the keys of the dictionary. For key in the name of the dictionary, and then you can print them one by one. So it looped through all the keys and it printed them down: name, field, and contribution. And you can also loop through the values in a dictionary. So you can say for value in person info dot value. So here we are specifying dot values. Here we are not, because it's by default. If we say dot keys, it still works. So when you don't assign something here, when you don't specify, it assumes that you are referring to keys, and it prints keys anyway. But for values, you have to specify that you want to loop through the values, and As you can see, we got a list of all the values in our dictionary. Now, can you also loop through both of them? Of course you can. We say for key comma value in person underscore info, which is our dictionary dot items, each element within the dictionary. And then we are saying print the key and the value. And you can see that this time we will print both the key and the value as a pair. This is more or less what you need to know about dictionaries. Dictionaries are very important. Very often you will be working with dictionaries in the data science and AI field. So do try to spend some more time, do some more examples on dictionaries. Now let's look at sets. What exactly are sets? Sets are in fact quite interesting. So a set is like a list but with two special properties. One is that you cannot have duplicate entries. Now, a list can have duplicate entries. You could repeat the elements within a list, but in a set, you can't repeat the elements. And if you do, if for example, if there is a list which had duplicates, and now you're transforming that list into a set, the set will automatically remove the duplicates. It will only keep the unique elements. We'll see it how it works. And then a set does not guarantee a specific order of element. So if you recollect list, the list had a specific order. The elements were in a specific order and you could access them in the same order. But set doesn't have any order. It's just a group of elements, unique elements. There's nothing like this element comes before this element or this element comes after this element. There is no order. It's just a group of unique elements. Now let's look at how we can create a set. Sets are defined by curly braces or curly brackets, which is same as for dictionaries, but there is a key difference. The difference is that the dictionaries had a pair of key value pair. They had key value pairs, but the set only has individual elements. That's how you will recognize between a dictionary and a set. A set will have individual elements while a dictionary will have key value pairs. So let's first define this and see. Now notice one thing. When we define this set named unique numbers, we actually gave 4 two times. Yet, when it created a set by the name of unique number, it kept 4 only once, which is it removed the duplicate. This is a unique feature of set and this is what it is mostly used for. It is very easy to remove duplicates with the use of set if order is not of any importance. Now you might think that we are maintaining order here, but we are actually not. We cannot refer to these elements by their index because there is none. Let's check that. Let's check that here, right? If we try something like this, let's say 0. This will raise in fact, since I have GitHub Copilot on my system, it's giving the error even before I execute the code. Because set does not have an index. There is no order. You cannot say that the index for 1 is 0 and index for 2 is 1. No, there is no index. Now let's delete this. So if the order of the elements is not important, don't want to access the elements by indexing, and you want a unique set of elements, then using set is a good choice. Let's look at some of the operations that you can do with a set. We can add elements to a set. So we can add elements to a existing set using the inbuilt .add method. Let's execute this code and see. So we added 6 at the end of it, at the end of the existing set, which was unique numbers. Now let's see what it does if I try to add the 6 again, because from what we know, sets does not allow duplicate numbers. So if we try to add 6 again, you will see that nothing happens. I mean, you will not see a duplicate 6. If we try to change it to 3, same output. The set remains as it was before. But if you want to add something else, a new number, it will add. Now, how do you remove an element? We can use the dot remove method, and we can give the element itself, the item itself. Okay. So say if you want to remove 4, we can say unique numbers dot remove, and then we can give the element that we want to remove within the bracket, and it will remove 4. We can also check if a particular element exists in the set or not, similar to what we did with dictionaries. We'll say if 3 in unique numbers, we know that 3 is there, then print 3 is in the set. And it does, because it does find 3 here. If we try to check for something that does not exist, it will not print that. Let's make it 3 again. Yeah. Next, we will look at set operations. Now, if you can recollect your high school mathematics, I'm pretty sure all of you would have a chapter on sets. And you would have done operations like A union B, B union C, A intersection B, A B minus A, that is the difference. The same applies here as well. You can do all those operations with the sets that we have in Python. We can have A union B, A intersection B, B minus A minus B. And this is how we can do these operations with set. We'll first define 2 sets. Set A is 1, 2, 3, and then set B is 3, 4, 5. We can actually have more than 2 sets, and then we can do these operations with more than 2 sets. But for simplicity, we'll keep it to 2 for the time being. And then here we are doing set A union set B. This is the operator for union. Here we are saying set A and set B. So this is the operator for intersection. And then we are saying difference set A minus set B. So set A union set B means that you are combining elements, all the elements from both set A and set B without the duplicates. So if there are duplicates, those duplicates will be dropped. But you will have elements from both the sets. So if you look at our 1, 2, 3, set A and B, 1, 2, 3 and 3, 4, 5, we know that 3 is a duplicate in both of them. So set A union set B should give you 1, 2, 3, then 4 and 5, because this will be this duplicate 3 will be dropped. Then intersection only gives those elements from A and B which exist in both of them. Now if you look in our example, only this 3 exists in both of them, so it will return just 3. And then A minus B will give those elements that exist in A but not in B. So what do we have? We have 1 and 2 which exist in A, but it does not exist in set B. The element 3 exists in both of them, so it will be disregarded. Let's try to execute and see what we get. So as you can see, as we just discussed, for union we are getting everything from A and B without duplicates. This is the intersection, the only common element in both set A and B, and then this is A minus B. Everything that A has but B does not have. Now let's look at some of the use cases for dictionaries and sets in data science. Dictionaries are used quite often, but one common use case would be for mapping column names with the description of that column. Giving you a real world use case. So very often when I request data from my own data team, or even from third party at times, I receive that data mostly in the form of CSV or sometimes Excel or JSON. Now let's keep the example of a CSV file. In data science, you will have scenarios where your CSV will have dozens and sometimes even more than 100 columns. And the column names will not be very descriptive. It will not be easy for me at all to just look at the column names and understand what each column represents. In that scenario, and to be honest, in every scenario, I always ask for a separate file, and I call it data dictionary, which basically gives me the column names and the description of all the columns. So it basically is a key value pair, and that's exactly what a dictionary is. We have an example right here. So this is an example of how you can define a dictionary that contains feature description or column descriptions. So here we have three columns or three features: age, income, and churn. And then we are very specifically saying that, okay, boss, you have this column named age, and that age is the age of customer in years, not in months. Then we are saying we have a column named income, and that income is an annual income, not monthly income, annual income. And it is in thousands, not in lakhs, not in millions, but in thousands. And then we have a third column called churn, which basically is a term used for a customer who has left or not. So if a customer has left, we say that there was a churn. This is a feature that companies are very interested in. They would never want a customer to churn. And many of the data science use cases revolve around a customer churn. Now let's look at the use case for set. The most common use case is for cleaning lists. Here we are cleaning a list of cities. So we can say that our list, which is named messy cities, has New York twice, has Berlin also twice. So there are duplicates here. If we transform this list into a set, which we can do it just by saying set and then passing the list within brackets. So now this unique cities is a set that was created using this list. But this unique cities set will not have duplicates. And we actually now cleaned our list, and we can again transform this set into a list. But now we'll have a clean list, no duplicates. One thing to again remember is that yes, you can use set to remove duplicates. It's a neat trick, but sets does not preserve order. So if you notice here, Paris was here, the fourth element, 1, 2, 3, fourth element, but now it's the first element. New York was first, but now it is second. So sets do not preserve order. So when you transform this set to list again, please don't think that you will get the same order that your original list had. So if order is not important, you can use set to clean your list, to remove duplicates. Now we have one more example here. We have duplicate here. We have, of course, 3 is the first element, and then again we have 3 here. We also have 2 and 1 as duplicate. And in an ideal world, you would feel like maybe if you are removing duplicates, this should have been removed, and then these 2 have been removed. I mean 3, this 3, and then 2 and 1 should have been removed. So you should get something like 3, 1, 2, and then 4. But when you execute this code, you actually get 1, 2, 3, 4, which is not the original order, because sets again do not preserve order. Sets in fact do not have any order. This brings us to the end of today's video. We have some quick exercises. Again, as I always say, nothing too difficult that you cannot attempt. But if you feel stuck somewhere, do feel free to comment in the comment box, and I will try my best to answer them. And we will also now go through the questions that were present at the end of day 4. The first question was to create a list of your favorite data science buzzword. Now, I've given some examples. You can take other words. And then I want you to add one using append, dot append, then remove the second one, and then replace the third one with another buzzword. So first you have some buzzword in your mind, have some words in your mind, and then we can do this exercise. So the first one is, I'm first creating a list named buzzword, and I'm putting these words into that list. Let's execute this. So this is my list now. I'm adding one. So I'm adding a new buzzword. new word, you can say neural networks to this list named buzzword. Pretty straightforward. You'll see here I've used dot append, and now we have one more element that was added at the end of the original list. Now we want to remove the second one, the second element here, which is the second element, AI, deep learning. So deep learning is the second element, and we are using dot remove to remove the second element. You can also remove using index, and then you will be using the index 1, not index 2. That is for you to do, but I am using remove, dot remove, and we have here, we have removed deep learning from the original list. Next, we want to replace the third element with another buzzword. Now, for me, the another buzzword is data mining, and third element is nothing but second index. So I'm saying buzzword index 2, you replace with data mining. So our big data should get replaced with data mining. It did get replaced with data mining. So our next question is, if fruit is a list of apple, banana, dates, cherry and dragon fruit, what is the difference between delete fruit? We are using the keyword delete to delete or to remove the element at index 2, and then we are using pop to remove the element at index 2. Now, what is the difference between these two methods? And we did discuss this in the actual video, that delete permanently deletes. It doesn't return anything. It will delete the element at index 2, which is dates, but it will not return it to you. While pop returns, it deletes, but it also returns that element, and you can catch that element in a new variable if you want to. So we will execute this code and we will see how it works. Okay. So delete fruits 2, remove dates. We don't have dates anymore. And if we try to do this, by the way, which is again not allowed, you'll get a syntax error, because delete keyword does not return any value. But if you do the same thing with fruits.pop2, it will delete and return the element. So if you see, dates was removed from here with this statement, but now our fruit variable holds that deleted item, which is dates. So when you print the removed item, you will get your removed item right here, because now it holds the value that was deleted. The next question was, write a program to print only the even numbers from this list. So we have a list, and then we only want to print the even numbers. I want to change something here. I want to make it look beautiful. Yeah, better. And so first we are creating this number, this list of numbers, and then we are checking if the number is divisible by 2 or not, if the remainder is 0 or not, and then we are printing them. Pretty straightforward. The next question was, create a tuple of 3 immutable constants, pi, e, and the speed of light. This is the example that I have given. E is the Euler constant. You can take any other 3 constants that you want to. And then try accessing each item, and then try to change one. Of course, Python will not let you change. Let's first execute this line. Now we have our constant tuple. We do this. So we get the value of pi, the value of Euler's number, and the speed of light in meters per second. Pretty straightforward. This is how you create a tuple. But if you would try to change the value of one of the elements, of course, Python will give you error, which is pretty obvious. The next one was, create a list named features, and then these are the elements of the features: age, income, education, gender, and city. And then use slicing to grab the first 3 words from the list, so age, income, and education, and the last two words from the list, that is gender and city. So we first defined our list here, features. We have now features, age, income, education, gender, city, and then the first three is 0, 1, 2. Index 0, 1, 2. Hence, we have given it till 3 because the index 3 is not included. And the last two words is from -2 to n. So -2 is gender, index -2 is gender, and then from gender to the n, that is gender and city. And let's now print them. We are happy. This brings us to the end of this video. I will see you in the next one. In the next one, we will talk about something quite interesting, that is functions.